Alright, here we go. We got a new video on factoring. Now this is three new types of factoring for most of you. We have the difference of cubes, the sum of cubes, and grouping. So before, the only time you were able to factor something with two terms was the difference of two squares unless it had a GCF. Well, now you have two more. It's called the difference of cubes and the sum of cubes. Obviously it's going to be pretty similar. The only difference is what do you do when you have a minus and when you have a plus sign. So for these, I like to remember SOP. Same, opposite, plus. So when you're factoring the difference of cubes or the sum of cubes, what you're going to need to do is you're going to need to set up some parentheses. A small set and a bigger set. And the pattern will always be same symbol, opposite symbol, and the last symbol is always plus. So what are we going to do to put all of that information in? So since this is the sum of cubes, what you need to do is you need to cube root the first term. So the cube root of x cubed is x. And you cube root the second term. The cube root of 8 is 2. Now what you do is you take your first term, x, and square it and put it in the first term of the second set of parentheses. So x squared. Then you take your last term of the first set, square it, and put it in the last term of the second set. So 2 squared is 4. The middle term, all you have to do is multiply these two terms together. So you have 2 and an x, so that multiplies to 2x. And you're done. That's it. The difference of cubes and the sum of cubes are really short, quick, and simple as long as you memorize the pattern. So here's another one right here. This is the sum of cubes. So what you would do is a small set and a bigger set. Same symbol, opposite symbol, always a plus sign. The cube root of 8x cubed is 2x. The cube root of 27 is 3. 2x squared is 4x squared. 3 squared is 9. And 2x times 3 is 6x, and you're done. That's it. That's the sum of cubes. The last is when you have 4 terms. Now this is our first form of factoring when you have 4 terms. But if you remember Batman, also known as splitting the middle term, it's pretty similar to that. You just might have to go a little further when you're done. So grouping means you group the first 2 terms and the second 2 terms together. So we have x cubed minus 2x squared. So what you do is factor out the GCF of those 2 terms. So the GCF of this first set would be x squared, leaving you with x minus 2. Now you look at the second set. The GCF, since the first term is negative, the GCF of a negative 9x and 18 is a negative 9. And then what's left is x minus 2. Now just like Batman or splitting the middle term, the inside of your parentheses must be the same. And if it is the same, then you just need to write it once. And then what you do is you take your GCFs that you factored out and you write that inside of your second term. The only difference is when you were doing Batman or splitting the middle term, you were done. But now with grouping, sometimes you need to look out for something like this. That says x squared minus 9, which means that is the difference of 2 squares. So that can continue to be factored. So your final answer for this problem is x minus 2, x plus 3, and x minus 3, again because x squared minus 9 is the difference of 2 cubes, or 2 squares. Okay, so there you go. You have 3 new types of factoring. The difference of cubes and the sum of cubes, which are very, very similar, just the order of what you put your symbols. And then, of course, grouping, which is similar to Batman. So here are 3 more examples for you. I would like you to pause the video and try the first one and go ahead and press play when you're done with the first one and see if you got it correct. So let's see if you were able to do it. The first thing I hope you caught is the fact that you need to factor out a GCF of 2x first. That rule has never changed and it's not changing now. The first thing you should always do is look for a GCF before you start factoring. So that's going to leave you with x cubed minus 64 on the inside. So before you got started, you might have thought difference of two squares, but that wouldn't have worked out because x isn't a perfect square, neither is 2 or 128. And once you factor out the 2x, you see that you have an x cubed minus 64, which takes you to one of your new ways of factoring. So we leave our 2x, but now we have our small set and our bigger set. Same opposite plus, so we have a minus, plus, plus. Cube root of x cubed is x, square it, x squared. Cube root of 64 is 4, square it, 16. And x times 4 is 4x, and you are done. That is your final factored answer for that problem. So why don't you go ahead, pause the video, think GCF again, and try the next one. Hint given, factor out the x first, giving you x cubed plus 3x squared minus 4x minus 12. And then what you're going to do is you see you have 4 terms, so you're going to group the first 2 and the next 2. So don't forget about your x, but put them off to the side for a moment. Go ahead and factor out your GCF of this guy, which is another x squared, leaving you with an x plus 3. Factor out the GCF of this, which is a negative 4, leaving you with an x plus 3. Look at your insides. Are they the same? Yes, they are. So we have an x plus 3. And we have an x squared minus 4, which we see again is the difference of two squares. So your final factored answer is x times x plus 3 times x plus 2 times x minus 2. All right. And that's it for that one. These problems will get longer, so make sure you really understand all your factoring back from first semester and from Algebra 1. Last problem in the notes for today. This is kind of a throwback. This is not one of the new forms of factoring. This is, in fact, the difference of two squares. However, this is what I sometimes call a double difference of two squares, in a way. So you're just going to go back to your difference of two squares pattern. You have a plus and a minus. The square root of 81x to the 4th is 9x squared. And the square root of 16 is 4. But now if you look again, this is the difference of two squares again. So your final answer for this is going to be 9x squared plus 4. Remember, there's no such thing as a sum of squares. And then you're going to move to 3x plus 2. And 3x minus 2 for the difference of two squares of that term. Okay, that's it for this video. So let's recap really quick all of our forms of factoring. So when you factor, we have a lot of different methods of factoring now. I like to call it 7 different ways, but GCF is all by himself because GCF can happen with any number of terms, and it's always the first thing you should look at. But now, if you have 4 terms in a polynomial, your only option at this time is grouping. So if you group your first 2 and your last 2 and you factor out a GCF and the insides are the same, then you can group. If the insides are different, then that problem cannot be factored. When you have 3 terms, you still have your old school magic number game, what multiplies to the last term but adds to the middle. And you have Batman, also known as splitting the middle term. But now you have 3 different ways of factoring when your polynomial only has 2 terms. You have the sum of cubes, the difference of cubes, and the difference of squares. Remember, there is no sum of squares. All right, that's it for this video. This is Longo, and I'm out. See you, bye.